Come back to my YouTube channel. We're still under engineering science N4. We're still dealing with stress and strain in young modulus, right? So we have this typical question, which is question 7. We have stress and strain young modulus given 7.1. Read as follow: a pillar has a cross-sectional profile 45 millimeter multiplied by 45 millimeter, and do we have a dot there? And what do we have there? The maximum compressive stress cannot exceed 5.5 megapascal. We've given the stress says calculate the maximum allowable load on the pillar. We want to calculate allowable load on the, which is the force there. We've given this. This is same as length multiplied by height. This actually, you see, this is a square because those things is the same. That means this is simply just a square. The 450, our 450, we know how to calculate the area, isn't it? So this is millimeter, isn't it? So we can divide this by 1000, will be 0.45 multiplied by 0.45. This will typically equal to what? 0.45 multiplied by 0.45. Our area will be what? There will become 0.2025 meter squared. This is our area. We have what there? The stress. We have given the stress should not exceed 5.5 megapascal. What do we have there? Supposed to calculate the maximum force, guys. You know that the force, guys, the force is simply equals to stress divided by what? By area. So we have the stress there is 5.5 multiplied by 10 power of 6 divided by the area, which is 0.2025. So this is what we'll have there. What will be the force? So 5.5 times 10 to the power of positive 6 divided by 0.2025. The force will simply equals to 27.16. There must be in, that is the force. All right, this will be okay. This will be meganewtons. It's up to you. Which one do you prefer, guys? Do you prefer to be in kilonewton or meganewtons? It's up to you. If you want this to be in kilonewton, you divide by 1000. So, but let it be in meganewton. Let it be in meganewton. This is what we had. That force can simply equals to, we've seen that the force is equals to 27.16 meganewton. All right. So we've given here question 3 says we've given figure 3 shows a cliff type hook. Cliff hooks will be attached to a rope that needs to lift up a load. We've given the load. It needs to lift up the load. Here it needs to lift up. We clicked there's a load that needs to be lifted up there. Which is 15 ton. The maximum shear stress in the pin we've given there is 45. All right, what we're supposed to do here? So can simply raise your done with this one there, guys, as you can see. So there we want says calculate the diameter of the pin. We want the diameter there of the pin. How can we do that? All right, guys, you must know, if you're given a pin, always you must know, guys, if you're given a pin like this there, I'm focusing on this portion of the pin. You must know that if we're pulling up this thing here like this, there will be double shear. We're talking about shear there. There will be double. Always when you're having a pin or a hook, something like this, which has one, two. If you have one, two, three things, we have these two things inside the diameter. You must know this piece will be shared like this, guys. Will be shared like that. So this will have those piece, the smaller piece that will be taken up will be shared here double. Will be the both will be shared double. You see, will be shared what? Double. Will have a double share. Always you must know, must remember that will have a double share. So that means your area, if you're given this typical of question, your area you'll multiply it by what? By 2, or the diameter, whatever that you'll have, but the area must double it if you have given this, guys. So how can you go about this? All right, so we have the 15 tons, but guys, we know that 1 ton is equal to 1 kg, 1000 kilogram. Now we have 15 tons. What about kgs? You cross multiply, then our x will be 15 multiplied by 1000. Then this will be what? 15 times 1000 will be 15000. This will be what in kgs. Now we have converted. All right, so we have this to be in kgs. Our mass now, our load, we have this to be in kgs. All right, as we, what do we want there? We want to calculate the diameter. So you know that we know that force, or let me just do it like this. You know that we have the board. We have given the shear stress. The shear stress is equals to what? Force divided by area. But now remember, because it's a pin, will be shared there. We have indicated twice. You'll multiply this by 2, guys. Always when you're given this, a pin there with a hook like this, just know, guys, you check if you have 2 plates. If you have something like this, you count them. You see you have 1, 2. You double your area, please. Then you double the area. So we've doubled the area. So after you've doubled the area, remember we want the area. The aim, we have this, we have given, we have that, we are given. Okay, now I want to make the area the subject. If I make the area the subject, I was supposed to multiply by that side. Or let me just take it step by step so that you'll see. I will have 2a multiplied by shear stress is equals to what? Force. Then I want the area. Can make area the subject. I'll divide by these 2. I'll have force divided by 2, divided by what? By shear stress. Then divide by what? Shear stress. So this is what we have now. There, what do we have? We have that the area is equals to force over 2 multiplied by the shear stress, like this. Why do I calculate area? It's because I know the diameter, guys. The diameter is on the area part. Remember, guys, this is a diameter. That part area, so that is where I will get the diameter on the area. All right, because guys, the diameter, if I manipulate, I know this will be the square root of what? Of 4 multiplied by the area divided by pi, like this. If I do manipulations, why do I say so, guys? It's because area is equals to pi over 4 divided by d squared. Then if I manipulate, guys, this, I'll multiply, will divide by this, I'll multiply there, then divide by that, will be 4 multiplied by area divided by pi, will be over pi. Then I'll be left with d squared. Then I take the square root both sides. So I would left with this formula there. You see, so via manipulation, I know I need the area. There is our pi. Let me find this area. The aim is to get this area there. So let us calculate that area. So we know that our area force, we have given kg, guys, 150, 1000, which is this? It's 15,000, isn't it? Remember now, this is kg, guys, but when the force, we multiply this by 9,81, so that will be in what? In force. Remember, force is equals to mg. Don't forget to multiply by gravity. Then we'll have 2. The shear stress we are given is 45 megapascal into 45 times 10 to the power of 6. So this is what we need now. Now we're supposed to have our shear stress there. We are supposed to have our area. So this will simply equals to what? If I find the area, if I multiply them, let me take my calculator. Divide by 2. Here, 45 times 10 to the power of what? Of 6. This is the same as 1,635 times 10 to the power of minus 3. Obviously, it must be in meter squared. This is an area. So I've shown you guys we can find the diameter. I did show you how we can go about. I said now the diameter will simply equals to what? The square root. I've shown you manipulation 4 multiplied by area divided by pi. So this will simply equals to our diameter, the square root of 4 multiplied by area, 1,635 times 10 to the power of minus 3 divided by pi. Therefore, what will be our diameter? Square root fraction 4 times 1,635. Remember that 35 times 10 to the power of -3 divided by pi. All right. So what's gonna be the diameter there? This is what it's up to you. Which way do you prefer this to become 46? Okay, we'll have this value like this, guys. It's up to you. Remember, guys, you'll have this will be simply equals to 0,0456. Then we'll have 2 and what. So someone can write this in scientific notation. Someone can write this to be equals to 45 6 26 millimeter. Someone can write this in this format. This other guy maybe can round this to 1 2 3 decimal. This will be 56 like this. 56 meter. Then if I multiply this by 1000, some can write this to be, this is the same as 46 millimeter. So either way, guys, stick to what you think is good there. Stick to n. You can use any, guys, it's fine, it's up to you. So I can use this of the scientific just for argument's sake, or I can even use that. So by the way, our diameter is there. I'll just use this one. just there. So that is our diameter. But anyway, we have just calculated it, no problem. They just wanted diameter, so we have that diameter. I don't think is anywhere we're supposed to use it. Okay, there's no way that we have to use that diameter. So we have this question now, 7.3 says a tensile force of 85 kilonewton is applied to a copper rod, causing the stress of what, 30 megapascal. The original length of the rod is 4 meter. Young modulus of the copper is 117 gigapascal. 7.3.1 says calculate the diameter of the rod. Alright, so how can we go about this? See what we are given. We've given the tensile force and we're given the stress. So guys, the stress is equals to force over area. We want to calculate the diameter of the rod again. We'll use the same formula. We know our aim is to calculate what, the area. You can make the area the subject. This will be force divided by what, by stress. So we have here our force, there is 85 times 10 to the power of what, of 3, divided by the causing stress, which is 30 times 10 to the power of what, of 6, like this. So I've punched this to my calculator. 85 times 10 to the power of 3 divided by 30 times 10 to the power of 6. What can I get here? Alright, so this area will be will be equals to 2 comma, let me just say this will be equals to 2,833 then times 10 to the power of minus 3 meter squared. This is our area. I've shown you the manipulation, guys. Now you know, guys, that our diameter will simply equals to what, to the square root of 4 multiplied by the area divided by pi. This is our formula that I've shown you. So you can just substitute there. 4 multiplied the area is 2,833 multiplied by 10 power of minus 3. Divide this by pi. So now let us punch this in our calculator. What we'll get, that the diameter will be equals to what, either way, square root of 4 multiplied by 2,833 times 10 to the power of minus 3 divided by pi. This is simply will be 60,059 meter. This is our diameter, guys. This is what we call our diameter. Alright, so we have our diameter. What do we have now? Supposed to calculate the strain. Strain is equals to change in length over what, the original length. Alright, we have the original length of 4 millimeter. So we're supposed to we have that. It's another formula that says strain is equals to stress over strain, or strain is equal, sorry, what I'm doing is nonsense. I mean that what is this formula that says, it says Young modulus is equals to stress over strain. You see this one, there's this, guys, yes, there's this formula, guys, by the way, that says there's this formula that says Young modulus is equals to Young modulus of elasticity equals to stress divided by strain. Then here we want the strain. I make the strain the subject. I'll multiply there. Will multiply like that. Have this, then I divide by this. I will have this to be equals to stress over what? Over Young modulus. So we have the stress, which is 30 times 10 to the power of 6 divided by Young modulus. So here it's our Young modulus there. Alright, so we punch this now. Let's see what I will get. Alright, what will then now our strain, what will be the strain there? 80 times 10 to the power of 6 divided by 117 times 10 to the power of 9. Alright, our strain there will be 256, 4, okay, 1, right, times 10 power of minus 6. Strain has no SI unit, guys. The strain, it has no SI unit. It has no SI units. It has no SI unit, the strain. Remember, this is measured in Pascal. The stress is measured in Pascal. Let me not use that megapascal. Also, this is measured in Pascal. Pascal and Pascal would cancel. It has no SI unit. So this is what we have. So guys, by the way, if you have not subscribed to my YouTube channel, may you kindly subscribe. May you kindly subscribe to my YouTube channel. All right, and may you kindly subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. Feel free to comment and share this to your fellow classmates. All the best. Thank you for watching. Right, all the best. See you on the next coming session. All right.